and post it. When your work is done, regardless of the due date. What does regardless mean? What does regardless mean? Nobody knows? That means don't worry about it. Don't worry about the due date. Regardless means we're not giving it regard. We're not going to worry about it. That's what regardless means. Okay? Yes? Regardless of the due date, what you're going to do is you're going to do a few steps. You're going to do one, put your name on it. Two, put the date on it. Three, affix them together. Staple if necessary. Maybe there's only one page. I don't know. Depends on what the assignment is. 4, put it in the box for this period. That's it. Then what's going to happen is then I'm going to take it every fourth period. Mr. Mendoza will take it and grade it, put it in the grade book. That's Schoology, okay, Power School. They're going to link together this year. And put the graded work in the folder labeled graded work in front of the class bin. The bin is that basket, all right? Is that clear to you? Are those steps clear to you? All right, let me see. Can you walk me through the steps? What's going to happen? Go ahead, tell me. I don't know your name. Mm-hmm.
Put your name on it, put the date on it.
What are you talking about? What are you going to put your name on?
The paper.
What paper? All right, anything you're turning in, correct? Do you worry about the due date? So I'm not worried about the due date. I'm done with it. I'm done with my work. Now what? What do I do? Thank you. And then you're done, right, with your job. What is going to happen to that work? Anyone at this table? What's going to happen to that work you put in the bin? And why don't we pick the back table? What's going to happen to that work you put in the bin? I can't hear you.
It's gonna be graded.
I still can't hear you.
It's gonna be graded.
We have to do presenter voice if you're speaking from across the room. Go ahead.
It's gonna be graded.
When?
For a period.
Fourth period, every day. And then what's going to happen to it? I'm going to put the grade in the grade book. Okay, and then what? And where is that folder? All right, and where is that? So right in front, there's a folder that's clipped closed. I clip it closed. It's going to have your graded work in it. It'll have, if there's lines to it, there's lines to it. I'm not going to put a grade on it, right? Where am I putting the grade? That's right. So you can grab your work without anyone seeing that you have an F or a D or a C or an A, right? It's nobody else's business what grade you got. It's yours. Is that clear? Is everybody okay with this system? All right. So everyone here, I think, understands. It seems like you understand, and that's how we're going to do it. So now, when you come in the next day, so now this is back to you, 5. When you come in back the next day, take your graded work and put it in your binder by date. All right. So remember, you're supposed to have a binder, not a notebook, not a spiral notebook. You're supposed to have a binder, not a folder. So you have this 3-ring binder, 1, 2, 3. You have a 3-ring binder. There's a hole puncher standing right here. You punch a hole in it, your graded work. You find the date in your binder because you put your date on it, right? Take that date, put it in the binder by date. So I took notes yesterday. I turned my work in yesterday. Today I'm taking notes. Tomorrow I get yesterday's work back. Where am I going to put it? In between those 2 days, right? Right back in that binder. So when I flip through that binder to grade your notebook, I should see notes, notes. Oh, there's the assignment. Notes, notes. There's the assignment. Notes, notes. There's the assignment. Correct? We're all good with that? All right. So now that we're clear on the instructions, now I would like you to, in a silent voice, follow this procedure to turn in any work you have to get done. See how it works, right? It works that way. It's not exciting. It's not terribly exciting, but it works. Okay, so now that we're clear on how the notebook's going to go and what we're doing, we need a binder. So I still see some people with spiral notebooks or no notebook at all, just a bunch of papers. That's fine, but I know we're only the second week of school, but I kind of expected you guys to have binders soon after the first day, but I understand that. So the next 3 pages is 12, 13, and 14. 12, 13, and 14. Those are the next 3 pages. There is a page 11, but 11 has nothing really to do on it. Okay? It has some checklists which are important because when you do research projects, you should do all those checkpoints. But today I'd like to focus on working on this thing called accuracy and precision. Has anyone worked on those words before? Have you never heard of the word accuracy? You have? Excellent. And the word precision? Have you ever heard of the word precision? Oh, you have? Excellent. I'd like to say thank you for the whole back table for being a silent voice and for taking notes and participating and responding to my question. So accuracy and precision, what do you think accuracy means? What do you think accuracy means? Just give me a guess. It's okay if you're wrong. Yeah.
Like how correct something?
How correct you are. That's right. That's a good answer. It's not just how correct is how, and let me rephrase that. When we say how correct you are, what do we really mean? I say how correct you are, I really mean how close to the real answer are you? Is that correct? Does that make sense? So if I ask you how much does it weigh and you weigh it and you come up with 29 grams, I say you're kind of accurate because the actual mass is 30. So it's how close to the actual number you are. Does that make sense? So when you're looking at accuracy, if we were playing darts, let's say, then that would be an accurate shot. These little red dots would represent a very accurate person. Somebody can come very close to the actual number, which is the bullseye. So accuracy means how close you are to the actual number. That's what the word accuracy means. Now, if we're talking about precision, what do you think precision means? You can just guess. You don't have to know the actual answer. If accuracy means how close you are to the actual number, what does precise mean? Yeah.
How far you are from the actual number?
It's a really good guess. That's a really good guess. It's not accurate, but it's a good guess. So would anyone here think that this grouping of targets, do you think that those groupings, do you think these marks are accurate? Anybody in here think these marks are accurate? No, not even close, right? Like it's all, like this is obviously more accurate than this. However, what do you notice about these marks? Even though what do you notice about these red marks versus these red marks? Yeah. They're really close to each other. That's right. That's good. So precision means the measurements are very close to each other. Perfect. That was something one of your colleagues actually just said. That wasn't me. I like that. So when I look at this here, these dots here, I can see they're very close to each other as compared to this circle of dots here. But obviously, I think everybody would agree these are more accurate while these are more precise. You can be accurate or precise or be both. If someone was going to be both accurate and precise, if somebody was going to be accurate and I'm sorry, it just drives me crazy when I make horrible circles. I can't take it. I shouldn't let it bother me. Maybe it's a little bit of, maybe I'm a little OCD, but all right. My wife thinks I am anyways. So, look at this. All right, that's not great, but it's not bad. All right, so an accurate and precise would be something like this, where they are very close together and they're very close to the center. Do you see what I'm saying? The difference between accuracy and precision? Yeah? Okay. Because when the reason this is important is a lot of what we do in science, in biology and all the sciences, a lot of what we do is actually measuring. And our mistakes that we make when we're measuring, or the mistakes the machine make, and I shouldn't even call them mistakes. By the way, I want to remind you that something like this on your paper would look, on your paper, you would have your paper divided like so, with your name at the top and date. So, what would I write over here? When I get home, you don't have to do it now, but what I would write is just, I'm going to help you do it because you're new to this. I would write accuracy versus precision. So what you need to, when you think about measuring, have you ever seen a balance, a scale? Have you guys ever seen a scale? See that blue thing up there that's at the top? Who's tall here? Would you mind, are you tall enough to grab that blue balance or scale at the top of the cabinet? If you're not tall enough, don't worry, I know I'm not. Be careful, it might be, there you go. Come here and put it on that front table here. This is a balance. You've seen these before? Can you put them on to 0? So the balance looks something like this. You have a machine here. Obviously, this is schematic. I hope you see it's a schematic. All right. And then it has 3 bars. There's 3 there, right? 3 bars that go across. Do you agree? And then it has, over here, it has a little bit of a loop, and then there's a big base. And then, so we missed that whole discussion, but the calibration of machines is necessary because over time things get bent. If the joystick controller in your Xbox or PlayStation, if it gets bent just a little bit, then when you go to push left, it doesn't go quite as smoothly as you like, which could mean the difference between winning and losing. If your button's sticky, you're pushing it, but it sticks down, and your guy freezes, and you get smashed by the giant rock or whatever the video game is. So machines like this also need calibration. You see, this is 0 right now because you see all the weights on one side. If I move this over to the 1, and I put it at the 1's place, that says it's 1. If I move it all the way over here to 10, notice it's up. According to that, that's 10 grams. Is it though? I don't know. That's what that machine says. But how do I know it's 10 grams? What do I need to do? Calibrate it. I have to calibrate. I have to make sure that it is what I have to make sure it's as accurate as I can make it. So what we do is we put a known weight. I pick something up I know is 1 gram, and I put it here. And then I move this over to this 1 gram. If it doesn't balance, what do I know? If I know, put something here that's 1 gram, and I move this over to the 1 gram, and it doesn't balance, what do I know? It's not 1 gram, so the machine is off, right? I know my 1 gram is correct because I know that's true. All right, that value is set. So now I put it here, and that's not measuring a gram. There's something wrong with this machine. I got to calibrate it. Just like your joystick, I don't know if you know this with your controllers, but you can take them apart. It's I have a fancy one they're magnetic, and I can take mine apart and I can adjust the little screws in it so that it goes back, to center. All right, that's my joystick at home, my controller at home. But here, there's a little wheel here that we can make it balance. It calibrates it, moves the weights just slightly to the right or slightly to the left, and lets it find the balance, actually get to that 0. And then once I get it to 0, now I know 1 gram is a gram. Then I can test a 5 gram and a 50 gram. And once I know the known weights are working, now I can work with my experimental groups. So this is known as calibration. We're improving the accuracy of the device. And every machine is done differently. And there's going to be a quiz on this tomorrow. So with calibration, the quiz is going to be, what is calibration? That's making the machine as accurate. I'm not even going to say machine, the measurement, because it's not always a machine. The measurement as accurate as possible. You have an exit ticket today. I need you to put your name on a piece of paper and put 1 word that you learned today. 1 word that you learned today, and put it right here on my desk on your way out. Have a good day. Sorry. So experimental design, and they use the words outline the investigation. So they want just kind of an outline. That means they don't want details. Root length varied during an experiment. The root length varied, and depending on concentration, notice I'm using abbreviations. And that helps me save time when I'm taking notes. I don't have to write out the whole word. I can go back later and revise it if I want to make sure that I have the whole thing spelled out correctly. It's part of the reason I'm not a great speller, because I'm a really good note taker. Not to say you can't be both, but you have varied depending on the concentration of hormone added to the agar. Now, you don't know what agar is. Here. You don't know what agar is, and that's reasonable. Agar, I'm going to explain to you now. The word agar is a seaweed protein. We'll be using it in class. Agar is a seaweed protein, and you don't know what a protein is yet. You will learn it very well. But it's a seaweed protein that forms a gel. All right. Now, what is a gel? Let's think about it. You've heard of this word gel before. Can you think of somewhere you might have heard something that sounds like gel? Hair gel. It has the same consistency as hair gel, a little more solid. Anything else? Something you eat. Jello, right? Jello gelatin. Has anybody here made Jello gelatin before?
What's that?
All right. Is it
Gelatin?
Jello gelatin? Have you made it? Gelatin?
Jello.
Okay. It's full. I love how you guys make fun of me. Its actual name is Jello gelatin. That's what it used to be called. Jello gelatin. Jello is the brand name. Gelatin is the form. But now everybody just calls it Jello. Just like Xerox, people would say Xerox copy. Now people just use the word Xerox. Or now maybe you don't even use it anymore. You just use a copy. What does what mean? Xerox is the company's name that first came up with the idea, or was a big company in copiers. Xerox no longer, I don't even know if it still exists, but it used to be so famous that instead of saying the word copy, we use the word Xerox. Can you Xerox that for me? Can you Xerox this for me? But it was really what we meant is, could you copy it for me? Correct? Jello is a brand name, like Nike, right? But people used it, we talked about making gelatin out of Jello so often that people then now just call it Jello. You don't even think about the word gelatin. Gelatin is the material, what the consistency of the material. So in any case, if you've never made Jello gelatin, you take a powder, it's a powder, and you pour it in hot water, correct? And you mix it with sugar usually, or some kind of flavoring. So let's think about it. You're going to take a powder, and it's clear. It's a clear powder, but I'm going to use, I don't know, blue instead. And you take that powder, and you're going to add the powder to hot water. Now that's all you do if you don't want any flavor. But what if you want flavor? What are you going to add to it? You can add different flavors. You can add bananas, a banana flavor. Like the powder in Jello gelatin, again the brand name. The powder in Jello gelatin has flavoring already in it. It could be cherry, it could be strawberry, or whatever. And it also has, usually you have to add, it doesn't come with it because it's a small packet, you have to add sugar. So you add sugar and powder, and then if you want, add it to hot water, you mix it up really well, and that makes a solution. This is called, and we'll go over it again later, but it's called a solution. A solution is a really good mixture. This is a solute, and this is solute. In other words, they're going to be mixed up really well. So the solutes are the things that are being mixed up. The solution is the whole thing mixed, that after it's mixed up, and this word here, this liquid, the water, is a solvent. Do you see how close these words are to each other? I'm going to warn you right now, this is where it's going to get confusing for you. A solution is the whole thing. The solution is the mixture. A solution is a mixture, things you've mixed together really well. So the solution is the mixture. You're mixing things up. That's all you're doing. A solvent is what is dissolving the solute. It's usually in the highest concentration. All right, so mixture, it's a mixture. It's not a chemical reaction, it's a physical reaction. It's a solution is made of a solvent, the thing that's dissolving the solutes, and then the solutes that you're adding to the solvent. So you add sugar and powder. Those are what are the things that are getting dissolved by what? The hot water. You heat it up so it dissolves easier. The warmer the material, the easier it is to dissolve it. So now you have this stuff that's cooling down. Some people can, you can put anything you want in there. People put little chunks of banana in there. Some people put little strawberries in there. You can put bacon in there. It don't matter what you put in it. I don't know why anybody would do that. I'm just saying you can put whatever you want in there. It doesn't matter. It'll mix up. It's just a mixture. The interesting thing is the Jell-O. Now, Jell-O gelatin is not made of seaweed. Jell-O gelatin is made of pig's bone. The marrow from pig has a protein that makes a gel. And when you cool it off, you lay it in a bin, and you can it'll make whatever shape you want. You want a star, you put in a star mold. You want a Santa Claus, put in a Santa Claus mold, whatever you want. And what happens is the proteins, they're really long, and they start to do this. They form a matrix. If you looked really close up, they almost look like a shirt. They start to form structure. So instead of having like a liquid that flows, you have a Jell-O that kind of it's called a colloidal suspension. They form this matrix that holds its shape. Okay? So it's kind of part liquid, part water, part solid. It's suspending whatever you put in there. It's suspended in there, and you can cut it out into a cube and eat it because it has everything in it is edible. So there's sugar, there's flavoring, there's the protein. It's not very good protein, but still a protein that holds it all together. Does that make sense? And of course, water. Yeah. Yeah. So that's Jell-O gelatin. But we don't use Jell-O gelatin in a lab. It used something that's very similar. When it forms that gelatin, though, it's a little harder. And when we do it in class, you'll see it. It's a little tougher, a little less floppy than Jell-O gelatin. It's still very much like Jell-O. Can I go on, or are you still writing? All right. So a solution is a mixture. It's not a chemical reaction. When you dissolve something, you are not reacting it. It's not changing. It's just getting dissolved. Look, you got water, and you put sugar in it. What does it taste like? Sugar water, because that's what it is. It's water with sugar. You didn't change the sugar, did you? Correct? Take that sugar, add it to butter, put it in a pan, warm it up slowly. What do you make? Maybe a little salt. Caramel. Does caramel taste like sugar? It's sweet, but does it taste like sugar? No, it tastes better, right? It tastes different. It's because you've chemically changed it. You've changed it. It's not sugar anymore. It is still sugar, but just it's made bonds with everything else that you put in there, and it's changed. Its chemical nature has changed. An egg. Have you ever eaten? Would you take an egg, poke a hole in it, and suck out the egg? No. My grandma used to do that. They say it's good for you. It builds muscle. I would be very careful with that, though. You can get salmonella poisoning that way, so be careful. Sometimes the bacteria will grow in there. It should be relatively safe today, but you never know. Especially if they're organic eggs. Don't do that with organic eggs for sure. So, anyways, but do you eat eggs?
Yeah.
What do you do with eggs?
Cook 'em.
You cook them. What does that mean, cook them? You chemically change them. You change its chemical nature. You break bonds and reform them so that you can eat them, and it tastes good to your tongue. I'll be honest, my grandma made me try it once, and I will never do it again. It's slimy. It doesn't taste good. No, thank you. Old people used to do all kinds of bad things to us. It was crazy. My grandfather cut the head off a chicken once. Oh. And like, why would you do that to a kid? Why would you let a kid? Like, okay, you have to cut the head off the chicken if you're going to eat it, right? I eat chicken, okay. But you don't have to do it in front of the kid, right? Anyways, are we all clear? All right, so solutes are what's being dissolved. Solvent is what's dissolving the solutes, and the solution is what you have at the end. Please be careful. The words are very close together. That's going to happen a lot. If you're not careful on how you look at these three words, you're going to mix them up and you're going to get confused. All right, so we can do the same thing with Jell-O. But now we're going to grow bacteria on this plate, and we want to grow bacteria. In this case, it's not bacteria. We're going to put plant seeds, right? And we have these clones of plant seeds, and on this Jell-O plate, we're going to put these little. And you see it there in your drawing. You're going to grow these little seeds, and the seeds are going to grow little stems, right, and roots. And what you notice, what they said is, look, we put a hormone in here. The hormone, you know what hormones are. You've heard of hormones before. You may not understand exactly what they are, but you heard of them before, right? Hormones sometimes hormones can make you grow. Plants also have hormones. They're not the same as our hormones. I hear conversation. I'm fine with it. But please understand, if you're going to talk, you're not being disruptive. I thank you for that. However, I'm concerned that you're not going to be able to get the details of what we're talking about here. So hormones, it's a signal that you can add. We added it to this gel, just like you added flavoring and sugar to Jell-O gelatin. We can add anything we want into this agar. We have bacteria that grow on blood, that eat blood. Do you know what we put in the agar? So that we can grow the bacteria, what do we put in the agar? Blood. So we have blood agar. We have agar that we can keep some nutrients out of it. We can put nutrients into it. We can do all kinds of stuff with it. It's a really good medium for us to do experiments. So they put hormones in there, and they noticed that the roots were longer depending on the concentration of the hormone. Okay, so how do we design an experiment that's going to test how the hormone grows or not? Makes the plant roots grow. Does the hormone, for instance, make the root grow longer? Or does the hormone make the root grow shorter? It could do either one. Or does it do nothing at all? I don't know. So what we do is we set up an experiment. We set up a hypothesis. And the hypothesis would be, you can take your pick. You don't have a lot of information in this particular one, but I would say the higher, I'm just going to use arrow because we're running it. I don't know how much time we have left, but probably not a lot. The higher the hormone concentration, the longer the roots will grow. All right. So this is a testable guess. It's a testable guess. It's a guess, right? Scientific guess. I don't know that's what's going to happen. I think that's what's going to happen. Well, how do I test it? What do you think I'm going to do? Can anybody come up with any ideas what I need to do?
One thing with no hormones in it and another with hormones in it.
Excellent. That's right. We're going to have a bunch of different plates. We're going to have a bunch of different plates. That's absolutely correct. Have a bunch of different plates. And we're going to grow a bunch of roots on there. That's a lot of plates. We have to do experiments a lot. And when we do experiments, we have to do it a lot. And so we want to make sure that we have one group that has no hormones. Then we have, the one thing we have to make sure is that all other variables stay the same. We control them. So how much light the seeds get, how much water there is in the mixture, how much everything else stays the same. That's going to be key. We're going to stop there. I will finish this and we'll make sure to post everywhere. And I will finish this tomorrow with you. How are we feeling? Are we feeling okay? All right. So we know we have time, no quiz this week, but on Friday I'll make sure you know what's going to be on the quiz so you can start to begin to schedule out your study review time. All right, let me do attendance. It's not time to go yet, but it soon will be. Wrap up. All right. Ali is not here, right? Bennett. Thank you. Let me see Bennett. Let me see if that's you. Okay. Alka's here, right? And Anaya Bolden. No, absolutely. Thank you. Brown. Thank you, Miss Brown. I just want to see your face, trying to get your names down. Raven. Thank you, Raven. Khalees Drake. Thank you, Miss Drake. Dunlap. Daryl. Thank you. Dariel. Sorry. I'll get it right. Sorry. I called the girl a boy yesterday. I was like, I'm sorry. It comes out of my mouth. It's not in my head. I don't know what's wrong with me. Don't judge me. You'll have to edit it later. All right. So we have to keep everything else the same. We only want to change one thing. What is the one thing we're changing? You said it already. What are we changing? All right, the hormone. How much hormone you add. So we're going to change one thing, and that's how much hormone we're adding. So everything else has to be the same. We have to control them. So how much light the plants get, the kind of plants, the agar we use, the concentration of the agar that we use. Not the hormone, though. Concentration of hormone is going to change. But everything else that these plants are all exposed to are going to have to be the same. If they're not, then you can't tell. If these guys, for instance, have more light than these guys, how do you know it wasn't the light that made the difference in the growth? You don't. Right? If these are wetter, if there's more water in these than over here, then how do you know it's not the water that changed the roots growing? You don't. Okay? So no hormones. This is called a control group. The control group is the thing we compare to. A control group is the group we compare all the other groups to. So we do it, everything else the same, and we have one group that I'm gonna go ahead and put in a little red box. These are no hormone added, and I see how long the roots grow. Okay. Then I start to add. I'm just going to put numbers. You don't have to understand what the numbers mean right now, but here in this group, I'm going to add 0.1 microliters. In this one, this symbol is micro. You'll learn more about what that means in a little while. But right now, just know it's a microliter is a very tiny amount. This is 0.2 microliters. This is 0.3 and 0.4 and 0.5 and 0.6 and 0.7. So then I collect data. So that's my experimental design. I'm changing the hormone, I'm only changing the hormone concentration. How much of the hormone I'm adding. That's it. That's the only thing I'm changing. Everything else stays the same. My control group has no hormones in it. And then I'm going to collect data. I'm going to put all the data. After I do that, I'm going to give it time. After some time, I'm going to collect data. I'm going to do the scientific method. I'm going to collect data. I'm going to repeat the experiment. Repeat it several times to make sure that the data is coming out somewhat reasonably. I'm going to analyze the data, and that's what we'll talk about tomorrow, is analyzing the data. All right? And then I'm going to come up with a conclusion. And that's what I would do if I were going to test this as a scientist. Pretty common sense though, right? You guys you knew, remind me your name, dear. Jiraiya. Say again? Jiraiya knew instinctually what you need to do, right? Jiraiya, have you had a lot of science lab experience? All right, so you've had some. She knew exactly ideally what she would do is she would change the hormone concentration. She didn't state it, but it sounds like she understood that everything else would have to stay the same. And she would just change the concentration. Then Wu said, we need a control group. We need something to compare it to. And that's correct. And after you have that, and you repeat it several times, and you collect the data, analyze it, and you have a conclusion, you've just done an experiment. That's all an experiment is. You have to have a control group, though. You have to have something to compare to. Otherwise, something could be going on that you don't know. For instance, what if the seeds themselves just grow at different lengths, just randomly? They have genes that make them grow at different lengths randomly. How do you know the hormones are having any impact at all? Now, what we would do, this was our hypothesis, in order to do a statistical test on the data, in order to do that analysis. Now I'm going further now. So if you understand this, you're likely going to get an A on the quiz so far. Now we're going to go a little more advanced. All right, so we're going to take it a step further and go a little more advanced. So if you're at the point where you understand this, you're good. So let's call that tier 1. All right. Now, if you're interested in doing a little bit further, let's look at something called the null hypothesis. Now, this is something we do to statistically, when we start to do this thing called analyze, when we start analyzing our results, we have to use something called the null hypothesis. So what we do is that we say, well, what if there is no difference? Or let me use another word, let me add an important word. No significant difference from the control. In other words, there's no impact of the hormone. The hormone has no impact. Now, when we do our statistical analysis, we'll use the null hypothesis to compare our results to. Either we're going to accept the null hypothesis and say the hormone has no impact, or we reject the null hypothesis and then accept our hypothesis. Remember what was our hypothesis? That the more hormone we added, the faster the roots grow. Does that make sense? Do we have any questions? So remember that part of your activity was to look at what is a null hypothesis. Remember that? So the null hypothesis just means you think that, in this example, you think the hormone's going to make the roots grow. In the null hypothesis, you say the hormone has no impact. And you test the null hypothesis. And if you see, using your statistical analysis, once you start looking at data and comparing it, and we'll go into that, into comparing averages, means, standard deviations, you can see a discussion of standard deviations up on the board. You can look at and say, okay, well, we have a significant difference. So I have to reject the null hypothesis and accept our hypothesis that the hormone does increase the root length. All right? Are we good with that? So that's the idea of a null hypothesis. I think that answered all the questions that we went over. If you want to resubmit your work that you've gotten back, you can correct it, revise it. What's going to be on the quiz next week? I'm going to tell you again, scientific, and I'll write it all out for you on the board. It's a scientific method, it's a control group, it's experimental design, agar, solution, solvent, solute, right? Will the null hypothesis will be on there as an extra credit question. Okay? So if you want to understand the null hypothesis, you want to take it to the next tier, right? And you want to really get into what a null hypothesis is, you can do that and get some extra credit. I'm going to take attendance, and then I'll dismiss you in a little bit. I'm thinking we have a few minutes still. Let me double check. I'm still trying to get this schedule in my head. Yeah, we got like 2 minutes left, so let me take attendance. All right, Jayla, you here? Anderson? Absent. Bahadur's here. Bell, Aubrey. Thank you, Miss Aubrey. I want to see your faces because I'm still trying to learn your names. Stephen Bennett. Thank you, Stephen. Bradley. Thank you. Butler. Thank you. Jamie. Thank you. Drake is here, I think. Drake, thank you. Feliciano is here. Anderson, Mr. Anderson. Foster. You were absent this week? Okay. I just want to make sure I didn't make a mistake.
Well, yeah, from your class again.
Yeah, from my class, yeah. Larry, George? Larry? Oh, thank you, Larry. Deanna, Heard? Thanks, Deanna. If I mispronouncing your name, please speak up so I can correct it. Morgan? You here, Morgan? Hi? Oh, I can't see you, dear. Try. You guys have to stay here, but thank you. I want to get your face too. Howard? Jariah, thank you, Jariah. Mariah. Mariah. That's cool that you write one right after the other. Olivia's not here. I don't think she's coming in this class. Madden. No, I know her face. Madden. I got Madden. Massey. Thank you, Massey. Miller. Thank you, Miss Miller. Moran. Giselle. No, Giselle? Oh, where? Let me see your face, Giselle. That's you? Well, she didn't say here when I was looking right at her. She just stared at me. Chivundo? Did I say it right? Oh, my God. Chivundo. Thank you, Miss Chivundo. Ote, thank you, Ote. Elliot, absent. Paul, thank you, Paul. Peterson,
Here.
thank you, Mr. Peterson. Smith, if I called your name, you can go. Smith, Jayla Smith, thank you. Phoenix, thank you. Lou's here. Worley, no Worley, absent. Robert Young is not here. And you're Wiley. Isaiah, is there another Wiley, I wonder? Or do I have you in the wrong class? You're Wiley, right? Yeah, come here. Let me look at something. I noticed that even though I added you to my roster here,
Bye, Mr. Mendoza.
have a good day, kiddo.
You too.
Even though I added you to this, I'm going to give you a pass. All right, so I think I have you third. Don't worry about that. You have nothing there. See, you're my third period. That's you. You switch from third period. I didn't mark you absent third because you're not there. You know what I'm saying? You're second. So I have to email them and tell them that I have you on class. Hold on, let me give you a pass. That's probably where you're going to. Who's
supposed to be the
computer science, English, math?
I'm gonna start with Ed.
Ed?
Yeah.
What teacher starts
Down the hallway.
right in this hallway? Krishan? Get ready for class, ladies and gentlemen. Hello. I love that people are putting their work in the bin and they're getting their binders out. I see you putting your binders out, your pencils, and drawing your lines for Cornell notes. I see you doing that. I don't know your names yet, but I'll get there. So you're doing the right thing. Putting your stuff, your staplers are over there, and there's one here. You have, make sure your name and the due date is on it. Some people are turning their work in. Remember your work, when's the deadline for your homework?
August 26th.
August 26th. Now, someone want to close the door when you go put that over there.